So here is going to be a little review for your quiz for this workshop. And first question here, we're just going to jump right into it. We have this elementary school teacher here, $400 budget. We have a budget breakdown of percentages. So quantity A, the dollar amount of supplies other than ones listed, and or $50. Which one is greater? Which one is greater? So we can do this quickly in Excel. We might as well, because we'll be using this throughout the course. We can take that 400 times it by 25, and we can actually copy that down. Now let's see if this works. Now, see, the thing is that didn't work. So what happens here is what we can do instead of that is we can actually put these dollar signs around the A1, and now that isolates the A1. And so we can now scroll down here, and there we go. So now let's take a look again. So this says $400 budget each year for classroom supplies. 25% of the budget can be spent on classroom decor, 20% on pencils and markers, 50% on rewards, and 30% on field trips. Quantity A, the dollar amount for supplies other than the ones listed. Oh, there's a key there. It says other than listed. Right over here, let's add those percentages up. Let's equal sum. Highlight those guys there. Oh, made one mistake. Forgot my parentheses. That's why they made a little error there. And let's see, that's actually only 90%. So we're actually missing 10%. So let's do 10%. So 0.1 is 10%. Let's just drag that formula down again. And we notice that 10% is only 40% of the budget, $40. So gotta be careful of the wording. Obviously, we just saw right there, other than the ones listed. Wording is very important because the other ones listed is only 10%, which is 40. So which one's bigger, 40 or 50? Well, quantity B is bigger. A student is living on a budget of $1,500 per month. He is spending 24. Oh, here's another budget one. So now we're at $1,500 a month. We have a similar breakdown. Represent this information in a pie chart. Calculate the dollar amount the student spent on bills. 25% of his budget rent, 20 on food, 15 on bills, 30 on fun. All right, so we can just simply stay with the same chart here, 1,500, and we can change these percentages here. So we add, 0.25 is right there already, 0.2 same, 0.15, 0.3, and let's get rid of these guys here. So we don't really need those. All right. So let's take a look, make sure we got everything. Very similar to the first one, 25, 20, 15, 25, 20, 15, and 30. Okay, 1,500 per month. And it says, represent this information in a pie chart. Well, I have to be honest with you, you don't really need to make a pie chart, but we can if you want to. Calculate the dollar amount the student spent on bills. Bills is 15%. 15% of 1,500, 225. Now, we can do this by hand. You can use a calculator. So let's take a look at the calculator. Some love the calculator instead of just using Excel. So calculator. Here we go. So we are at 15%. So 15% of 400. Oof, I almost went back to the first example. 1,500. There we go. 225. Okay. Calculator, by hand, Excel, all sorts of tools for you. All right, let's take a look at the next one. Molly currently makes $42,000 a year. Whew, man. Won't go there. Teacher's budget. Here, her contract includes a 3% raise each year. What is Molly's salary after 30 years? Ooh, after 30 years. 3% raise after 30 years. Let's take a look at what that means here. So, we can make a chart if you want to. Again, just emphasizing Excel. So we're starting at 42,000. Let's get rid of this stuff here. Okay, so her contract includes a 3% raise each year. So we can take this cell, equals this cell times, I almost did a very classic mistake that students make. Now, you can do 0.03% here, and that's what would be the raise. Then you can add it, or think about this. A 1 represents a whole. If I did 1 there, that's 1.03. That's 3% more than your original. So if you times it by 1.03, it puts it right back in there for you. So that's the raise after 1 year. But then it's a 3% raise on top of that. Ooh. So how are we going to do that? Now, it's going to be this, but then it's going to be 3% of that. So we could now take that formula. Let's see if we can get this to work. Equals this again times 1.03. Now, so it's 3% more of that. So we can actually do this in a much quicker, much easier way. Now, again, let's think about, interest, how interest accrues. And sometimes we can think about compound interest or simple interest, either one. But we can use a similar method to do this. So interest, simple interest. Now this is yearly. So since it's yearly, I mean the compound period is 1 year. So we don't have to deal with the whole compound interest formula, but we can deal with some of it. And so it's a very simple process that we use with calculating interest. So we start with 42. So that's what we started with. And then it's going to be times the percentage. Basically, this here is 1 plus that percent. So right in there, let's just emphasize this a little bit more. So that's just 1 plus that 0.03%. Of course, you have your whole and you're adding 3%. And now, the exponent is actually going to be the compound periods. So now, since we're dealing with 30 years, and we're not compounding any more than just yearly, the exponent is going to be 30. And so instead of drawing it out the long way in Excel, I mean you can also put this short method in Excel, or this one, it can be very easily done in the calculator. So let's put it in the calculator. So calculator here, 42 times 1.03 risen. Where's my exponent? There it is. 30. Sorry, 30. There we go. And there you go. So after 3% raises every year for 30 years, we're looking at 101,945.02. Man, that's going to be exact. So that's what that would be. Now, if you're unsure about that, you can actually set it up so in Excel or on the calculator, and you can go times 1.03, enter, and then you can times that answer by 1.03, and you can do that 30 times. That's more than feasible. You can do that 30 times. Or let's go back to Excel to see how we can do it in there. And so here in Excel, we'll just go here and we'll do equals 42,000 times that. And then we have to just tell Excel one more time to do that times 1.03. And so it said after 30 years, after 30 years. So click down. Whoa, way a little too far. There we go. And there it is. So after the 30 years, there is the amount. So lots of ways to do it, not just one way, many ways to go about this. All right, let's truck along here. Let's not take too much longer. All right, so next question here, we have another percentage problem. So let's dive into this a little more closely. So we have living expenses of $1,500 a month, 25, 20, 15, 30, very similar to before. This time says calculate the dollar amount the student spent on fun. So let's just do this much quicker. Let's go right to the calculator here. All right, right in here. So we're looking at fun. So fun is 30%. Oh, maybe we have a little too much fun. So 0.3 times 1,500, and we have 450 on fun. All right, let's keep trucking along. Okay, let's take a look at this number 5 here. Let's get some circles for us for our Venn diagram again. And there we go. All right. Oh, made that a little bigger by accident. So we have 75 respondents said they listened to AM. 45 listened to FM. 25 said they listened to neither. 30 said they listened to AM versus FM. Okay, so lay AM and FM. Now let's just fill this out. So we have 30 listen to both. We have 25 say they listen to neither. 25 listen to neither. And let's take a look. So we have those two parts. And now 45 say listen to FM. So that's, all right, let's label. So we have FM, AM. All right, FM, AM. Now 45 say to listen to FM. So I mean, that leaves us with 15 here. And then we have 75 that say to listen to AM. That's must be a really old question. So 75 is the whole circle. So 75 minus 30. All right. So 75 minus 30. We have 45. So 45. All right. So 75 listen to AM, 45 listen to FM. So that whole circles have to add up to those numbers. 45, 30, 75, 30, 15, 45. 25 listen to neither. All right, so let's see. The number of respondents who listen to AM radio, to only AM radio, which is 45. Number of respondents who said they listen to neither, 25. So the AM is larger. A is larger. All right, so that's number 5. Now this is much more simple than how it's presented, but 1072.33. All right, so let's just go step by step. He did buy the iPod. He did buy 2 shirts. That's what he had. Then iPod was defective, he returned it. And there's your balance. Okay. We have 140 members, so that's the total. So we have 140 total. That's my total. 80 listen to rock, 75 listen to heavy metal, 42 listen to both rock and metal. Alright, so the number of members who only listen to metal, so we start middle out. So we have 42 in here. And so we have 80 listen to rock. Oh, let's label them. So we got rock versus metal. I feel like I'm dealing with a science course here, rock and metal. So we have 80 listen to rock, 80 minus 42. So we have 38 over here. And then we have 75 listen to metal, 75 minus the 42. So we have 33. Number of members who only like heavy metal. Heavy metal is 33. Number of who only like rock, 38. So the B is going to be greater. We have a breakdown here of percentages. So the market share of wireless service providers is broken down here. I don't know if that's actually completely accurate, but it's just broken out for this question's purposes. How many people would you expect to have a different wireless service provider than the one listed? For our purposes, we assume everyone has a cell phone. Everyone has a cell phone. Now I have a cell phone, but I'll fully admit I do not have a smartphone. Some people think I'm nuts, but I don't. That's besides the point. Here we go. So we have all these percentages. Let's add those percentages up to see. All right. So we add those up. We have 11 plus 31.9, 31.1. All right. So let's make sure we have them. 11, 31.9, 31.1, 16.7. Okay. So, all right. So that's 90.7%. So let's subtract that. I know I did it a little backwards, but 9.3% have, so we have 9.3% don't have them. Now, to make that as an actual number to use, move that decimal 2 times, and that's 0.93. Remember, this is a percent. I'm dealing with percents. But to use as a number to work with, we're going to move that twice. So 0.093. We're going to use that number. So we have the percentage, 9.3%, times the whole, 41,250. And so we have this here, this number. And now technically there's not going to be a part of a person, so there's not going to be 0.2. These are percentages. So some students, when they come across a question like this, they argue with me and get mad. Please don't get mad. So we have about 3,836 people that do not have one of those carriers. So scrolling back to what we did with number 5, very similar numbers here. Let's take a look. This one here, We already had it filled out, so if you're working through your notes, you would have it too. The number of respondents who participated in a survey. Oh, okay, so we got to add all these up. So we have to add all these up. We have 45 plus 30 plus 15 plus 25. 115 people in the survey. The number of respondents who listed only FM radio. Oh, this is a pretty simple one. So only FM is 15. Obviously, the total respondents for the whole survey is going to be greater. Okay, all right, let's keep going here. Consider the bar chart which shows the favorite foods of a group of people who were surveyed. All right, so the number of people who choose pizza as the favorite food, the number of people who choose hamburgers as their favorite food. All right, so we have pizza, we have hamburgers, and so let's look a little more closely. So I have to say, looking at this question, look at these bars, it's really not broken down very well. I mean, if someone said hot dogs versus hamburgers, okay, we can distinguish that. Pizza versus hamburgers, it's actually really close there. Obviously, the pizza does look a little higher, but just in case if this quiz marks this wrong, just make sure you email me. And I'll check this out, because that's a little, I guess the word ambiguous or unclear. It is close. I mean, it does definitely look a little bigger to me, but we'll go with the safe one of A. But if some question comes like this and it's really close and it's hard for you to choose and you pick wrong, I'll look at it and see. But make sure you're making as best educated decision as you can for that answer for something like this. All right, next, the population of Springfield is currently that. If Springfield's population increases by 2% of the previous year's population, use this information to find the population after 6 years. Oh, so this is going back to that, like a compound interest type problem. Okay, similar to what we did before, but instead we'll just do it one method in here. 41,250 times, and so 2%, so that's times 1.02. And we're going to raise that to 6, because we're looking at a starting point of 41,250. 2%, going up by 2% every year for 6 years. And so we're left with 46454. I'm glad these aren't too close to these numbers. I mean, this one is pretty close, but it's more closer to 454. I'm just really glad this didn't say 45 versus 44. I wanted me to look at the last two numbers. So there you go. All I was speaking of there was making sure that there was two answers that were not so close that it was not obvious what the answer would be. All right, let's take a look at the next one here. If you needed to estimate the value of 26 divided by 5 without using a calculator, which whole number would you say is the closest to? All right, so 26 over 5. You didn't have a calculator. I was just asking you, hey, which number would this be closest to? Well, we can think about 5. We have 5, 10, 15, 20, 25, 30, 35. So 26, if you think about multiples of 5, falls between 25 and 30. So it falls between those two. But you notice the 26 is much closer to the 25. And so 25 divided by 5 is 5. 30 divided by 5 is 6. So this number will be between 5 and 6. Now, since this number 26 is closer to the 25, it's going to be closer to the value of 5. So let's take a look at these answers. It would be closer to 6. No, closer to 5. 5. All right, so we're looking at these two, because the nearest values of 26 that are multiples of 5 are 25 and 30. 25 is close to 26. Okay, sounds good. It will be close to 5 because the nearest values of 26 is 25, and the square root of 25 is 5. So that one looks like it might have two answers, but let's think about this here. So if it would be close to 5 because the nearest values to 26 is 25, and the square root is 25 is 5. I mean, to me, logic shows both of them, but when it comes to division and trying to find what it's more closest to, I would have to lean towards this one, because when it comes to square roots, sometimes those numbers can be pretty far apart, and square roots are we dealing with multiplication. So, but when we're dealing with 25 and 30, we know it's definitely between 25 and 26. And we're also dealing with whole numbers too. So we're dealing with two of the whole numbers that it falls between, the 5 and 6 here. And we know that, again, the 26 is closer to the 25. So I would lean towards a stronger answer for this one, for a possible answer. I can see how some students may think that that third one could be a possibility, and I have to agree, it can be a possibility. But the stronger one would definitely be B. Molly currently makes $40,000 a year. Her contract includes a 3% raise each year. Oh, similar question to what we had before. Okay, so let's take out that calculator here. It's a similar one to this population we just did. So we have a $42,000 a year times raise of 1.03, risen to, this time we're dealing with 5 years. So we have that value after 5 years. So we have 48,689 versus 48,880. Ooh, that was close, but B is larger. Next we have, there are 7 continents forming the Earth, forming the Earth's land, which makes up 57.5 million square miles. Whew. That's 30% of the Earth's land is Asia, 20 Africa, 16% is in North America, and so on. The amount of square miles for North America versus 10 million square miles. All right, let's calculate that. So let's take a look here. So North America, 16% is North America. So we're at 0.16 times 7 continents forming the Earth's land, which makes up 57.5 million square miles. So 16% of 57.5 is 9.2 million square miles. 9.2. So we have 10 here. That 10 is larger. This last question here. So we're looking at this chart here. We have Jake. He's chiseling on a plow in a field. Continues working. You know, when he started working, 80 acres were already chiseled. And then after 1 hour, 95, 110, 125. So how many acres would be chiseled after Jake worked for 12 hours? 12 hours. So we can think about this and how much change is happening per hour. So we can calculate that quickly here. So if we do 125 minus 110, that's 15. If we did 110 minus 95, that's 15. If we did 80 minus 95, oh, I did it backwards there, but 15 again. So 15 each hour. He's averaging 15 an hour. So averaging 15 an hour. Now this is actually kind of bridging us into the next unit. So we start with 80. That's a starting point. And he's averaging 15 acres for every hour. So we're going to say that this X here is going to represent hours. So that X again represents hours. And so we're looking at after 12 hours, so we're going to do 15 times 12, and then plus that 80 that we started with. So 15 times 12 plus 80 would be 260. So we're looking at 260 acres. Okay. All right, and we hit submit. Oh, there we go. Good to go. All right, so again, for quizzes, I just wanted to run through a practice exam for you. I wanted to make sure you felt comfortable for it. So please just make sure if you have any questions, you need any help, just make sure email or text me. I'm here for you. I hope you have a blessed day.